In this problem, we will find IA, the current going through that inductor on the right, given that we know VS and IS. Now, if you spend any time with me at all, you will learn that I am just terrible at calculations. I make so many mistakes. So I have this all written out, and hopefully I can copy it correctly. Even that is not a given. But in order to minimize making mistakes, I start by working just with variables, and then I plug in order to do the calculations at the end. So we're going to start, and I thought the easiest way to do this one was with nodal analysis. And so I'll put VA right there, and then I'll call this ground. At this point, you might be saying, for some reason, that, well, wait a minute, that's a good place to put ground. I agree. What if you decided for some bizarre reason to put ground here? Can you do that? Sure, you can put ground anywhere. You just have to remember that voltages are all relative. So if you solve for the voltages with one ground, you've really solved for them for all grounds, and I'll show you how later. Now, don't go jumping to the end of this video to find out how just to do that part. Don't do it. Stop. No. Wait. I have to do all these calculations. You have to do all these calculations. And then you also are supposed to do these without using the complex features of your calculator. And so I did that. It makes me very unhappy to do that because I'm just terrible at it because I make so many mistakes. But I'm going to do that. You have to do that because I had to do it. And then I will at some point show you what to do if you put the ground in some other bizarre place. Okay, so we'll start with nodal analysis. In nodal analysis, I sum up all of the currents coming out of my nodes. So I really just have one node that I need to deal with here. I've got ground. I've got this VS over here, but that's easy. I know that relative to ground, the voltage on this side of VS is just VS. And so really I just have my only unknown here is VA because I know everything else. Now I am going to call this one, so I'm going to say that Z1 is 3 plus J4. So this is going to be Z1. And then I'll say Z2 is minus J4. So this is Z2. And then Z3 is 6. You might say, why do I have this weird numbering 2, 3, 1? It's just because that's how I did it, and I don't want to copy it differently than how I have it on my paper. Okay, so I'm going to sum up all the current coming out of VA. So remember, a current is your starting voltage, V1, minus your ending voltage, V2, over your impedance. That is your current. And so this first current going this way, our starting voltage is VA, our ending voltage is ground, so VA minus ground, VA minus 0 is just VA. So our first current is VA over Z1. Now our second current is the current going down here. Well, we know what that current is. The current going up is IS, so the current going down is minus IS. My next current will be the current going down this branch, and that will be VA minus 0 over Z3. So VA minus 0 is just VA over Z3. And then my last current is the current going in this direction. So my starting voltage is VA right here, so it's VA minus my ending voltage is VS, which is known. We know VS is 10. It's minus VS over the impedance between them, which is, we called Z2. And that has to equal 0. Now my unknown here is VA. I want to solve for VA. So first I want to get rid of the fractions. So I'll multiply everything by the common denominator. The common denominator is Z1, Z2, Z3. So I'll multiply everything by z1, z2, z3. And I will get, so VA over Z1 times Z1, Z2, Z3 is VA times Z2, Z3, because the Z1s cancel, minus IS times Z1, Z2, Z3, plus VA times Z1, Z2, plus VA minus VS times Z1, Z2, Z3 equals 0. Okay, now I'll leave everything with VA on the right side, everything without VA I'll take over, everything with VA on the left side, everything without VA I'll take over to the right side. So I have VA times Z2, Z3, and then the IS is going to go to the other side, so I'll get that in a second. VA Z1, Z2, plus, and then I will distribute this. So on this side, I'll have VA Z1, Z2, Z3, and then I'll take the VS times Z1, Z2, Z3 over to the other side. So on this side, I have VS Z1, Z2, Z3, and then I'll also take the IS to the other side, and I'll have IS times Z1, Z2, Z3. Okay, I should watch my paper more often. Y'all probably, I hope, caught my mistake when I multiplied VA minus VS over Z2 times Z1, Z2, Z3. The Z2s should have canceled, so this Z2 should not be there. So that will take away this Z2. And this is Z2. Let me make sure that matches my paper. Z1, Z3, yes. VS, Z1, Z3, yes. Okay, so now continuing to solve for VA, I'll factor VA out, and then I have Z2, Z3 plus Z1, Z2 plus Z1, Z3 equals VS Z1, Z3 plus IS Z1, Z2, Z3, and then I divide everything by Z2, Z3 plus Z1, Z2 plus Z1, Z3. And it cancels over here, so I have that VA is VS Z1, Z3 plus IS Z1, Z2, Z3 over Z2, Z3 plus Z1, Z2 plus Z1, Z3. Okay, so now it's time for us to plug in our numbers and do our calculations. And let's start by reminding ourselves what Z1, Z2, and Z3 were. We have those right here. Alright, and then what is IS? IS is 5 angle 30. So we have everything else in rectangular. Let's change IS to rectangular as well. So IS is 5 angle 30. To change that to rectangular, let's just realize what 5 angle 30 means. It means it's a distance of 5 from the origin and at an angle of 30 degrees, where this is our real axis and this is our imaginary axis. And so this side, and this was 5, this side is 5 cosine 30, and this side is 5 sine 30, and that's the imaginary side. 5 cosine 30 is 4.33, 5 sine 30 is 2.5. So IS in rectangular coordinates is 4.33 plus j 2.5. So now we're just going to plug all of these values in. So we get VA, oh, and VS was just 10. And so just because to make it match what I have on my paper so I can copy cleanly, I had this in the different order on my paper, so I just had this like this: Z1, Z3 over Z2, Z3 plus Z1, Z2 plus Z1, Z3. Okay, so IS is 4.33 plus J 2.5. Z1 is 3 plus J4. Z2 is minus J4. And Z3 is 6. Plus VS is 10. Z1 is 3 plus J4. And Z3 is 6. And this is over Z2 is minus J4 times Z3 is 6 plus Z1 is 3 plus J4. Z2 is minus J4 plus Z1 is 3 plus J4 and Z3 is 6. Alright, so now for this the numerator here, I'm going to FOIL my first two numbers, so I'll multiply 4.33 times 3 and then 4.33 times J4 and then J2.5 times 3 and J2.5 times J4. So 4.33 times 3 is 13 plus 4.33 times 4 is 17.32, so 4.33 times J4 is J 17.32 plus J 2.5 times 3 is plus J 7.5, and then J 2.5 times J4 is 16J squared, but J squared, oh no, it's not, it's 10. 10, it's 10J squared, but J squared is negative 1, so that's minus 10. And then minus J4 times 6 is minus J24. Plus, and I'll multiply my 6 times my 10 is 60. 3 plus J4. Over minus J4 times 6 is minus J24. I'll distribute this minus J4, so I'm going to multiply the minus J4 times 3 and the minus J4 times J4. So minus J4 times 3 is minus J12. Minus J4 times J4 is minus 16J squared, but J squared is negative 1. So minus 16J squared is plus 16. Plus, and now I'll distribute this 6. And I get plus 18 plus J24. Now I will combine my real terms and my imaginary terms in this first one. So 13 minus 10 is 3. And J 17.32 plus J 7.5 is J 24.82 times minus J 24. And then I'll distribute the 60 plus 180 plus J 240 over, and now I'll combine my real and imaginary parts in the denominator. 16 plus 18 is 34. Minus 24, minus J24 plus J24, those cancel, and I'm left with minus J12. So I still have this minus J24 to distribute to these two terms. So minus J24 times 3 is minus J72. And then minus J24 times J24.82 is minus 595.68 J squared, but j squared is negative 1, so that becomes plus 595.68 plus 180 plus j240 over 34 minus j12. Combine my imaginary parts and my real parts. So 595.68 plus 180 is 775.68 minus j72 plus j240 is plus j168 over 34 minus j12. But I need to get this into a plus jb form. I need a plus jb. And so to do that, I multiply by the conjugate of the denominator, 34 plus j12 over 34 plus j12. In the numerator, I'll FOIL. I'll multiply this times this times that, and then this times this, and this times that. 775.68 times 34 is 26,373.12. 775.68 times j12 is plus j9,308.16 plus j168 times 34 is j5,712, and then j168 times j112 is 2016 j squared, which is the same as negative 2016. Now the whole point of multiplying by the conjugate is in the denominator. You'll get this number squared plus this number squared. J minus j12 times plus j12 is minus 12 squared j squared, but the j squared is negative 1, so minus j squared becomes positive. Or in other words, when you multiply a plus jb times a minus jb, you always get a squared plus b squared every time. A squared plus b squared, because the middle terms cancel out. So the middle terms would be jab plus jab and minus jab. This last term is j minus j squared b squared. So that's minus j squared is negative 1. B squared minus negative 1 is plus 1. So that's where the plus b squared comes from. So this becomes 34 squared plus 12 squared. Now combining my real parts, combining 26,373.12 minus 2016 gives me 24,357.12, and then combining my imaginary parts, I get j 15,020, and then 34 squared plus 12 squared is 1,300, and then I just divide each of these numbers by 1,300. 24,357.12 divided by 1,300 is 18.74, plus 15,020 divided by 1,300 is 11.55, and so I get that VA is that number. Okay, so that's what VA is. What does my question ask for? My question asks for IA. I have VA. So I know that IA will be the current going here. So if I start at VA and I end down here at ground, then my ending voltage is 0 and my impedance is 3 plus J4. So IA equals VA minus 0 over, that was Z1, over Z1. And VA we have is 18.74 plus J 11.55 over Z1, which was 3 plus J4. So all we have to do on this one is rationalize it. Multiply by 3 minus J4 over 3 minus J4. We'll FOIL the top, and when we FOIL the top, I get 56.21 minus J74.94 plus 34J34.66 plus 46.22 over 3 squared plus 4 squared, so over 9 plus 16. And this equals 102.42 minus J 40.28 over 25. So I divide 102.42 and 40.28 by 25, and I get 4.097 minus J 1.611. Okay, so this is IA, but let's say we need to have it in polar form. So let's make sure we see what quadrant it's in. So you go out about 4 on the real axis and down a little more than 1.5 on the imaginary axis. So it's right here. So it's in the 4th quadrant. So we expect the real part is positive, as it is, because it's going to the right. The imaginary part is negative because it's going down. This is the angle we're going to want. So the magnitude of IA will be the square root of 4.097 squared plus 1.611 squared, and that equals 4.4. And our angle will be the inverse tangent of negative 1.611 over 4.097. And when we get that gets you an angle of negative 21.4 degrees. Now you always have to check, because the calculator is only going to give you the value that comes in this 4th quadrant. But the inverse tangent of that same number also could equal the angle in the 2nd quadrant. And so you have to always look at, well, where is my complex number? Is this the right angle for it? And sure enough, it is, because it is 21 degrees below the x-axis. If I was in the 2nd quadrant, I would add 180 degrees to that. And so IA equals my magnitude 4.4 angle negative 21.4 degrees. Okay, now I promised you that I would say, well, what if we put ground in a different place? And if I had to say, let's say I had, my problem was in this same circuit, it's interesting. Oh, it's because it's not part of the page. Okay, so let's say the problem was in the same circuit. Let's say that ground was right here. Ground was right here. But I needed to find out what VA was relative to this ground. Well, I tell you, I would work the problem the same way I just did, because to me it makes a lot of sense to put ground down here at the bottom, because then all of my nodal analysis equations work out just fine. So when I did that, then I got that this was 0, and I got that VA was, whatever VA was, 18.74 plus J 11.55. Okay, so this is using the bottom branch as ground. So now I want to find out So I'm not making this ground yet. I just want to know if the bottom is ground, what is the voltage right here? So I'll call that VB. Well, if I look at it, what I've got is I have VA, and then I have an impedance, and then I've got VB. And VA was 18.74 plus J 11.55. VB is my unknown. My impedance right there is 3 ohms. And I know my current is 4.4 angle negative 21.4 degrees. So I have VA in rectangular, and I have my current in polar. Let's see, I had my current in rectangular. What was it? 4.097 minus J 1.61. So I know that IA equals VA minus VB over Z, or IA, which is 4.097 minus J 1.611, equals VA 18.74 plus J 11.55 minus VB over 3. Multiply both sides by 3. I did this a different way on my paper. I was trying not to do that. 4.097 times 3, 12.291 minus J 4.833 equals 18.74 plus J 11.55 minus VB. I'll bring VB to this side, and I'll bring these two numbers to that side. So VB equals 18.74 minus 12.291, 6.449, and then I'll add J 4.833, so that's going to be plus 4.833 plus 11.55 is 16.383. So what that tells me, let me make sure this matches what I had here. I did it a different way. Let me make sure that does match. I have a sign wrong. You know, the only thing I did that's not on the page I messed up. Hold on. Okay, I actually don't have a mistake. I only thought I had a mistake. So, in polar coordinates, VB equals the square root of 6.449 squared plus 16.383 squared. Angle inverse tangent of 16.383 over, I don't actually know why I'm doing this because I don't think I need it, so I'm going to stop there, because what I needed was VB in this system where I had ground here at 0. And so when I had ground at 0, then VB equaled 6.449 plus J16 plus J16.383 or something like that. Okay, so now what do I do if I have to have this same circuit, but I need to get what my voltages would be if ground was in the different place? So if my question was, what is VA if my circuit looks like this? And I put ground there for some strange reason, and I want to know what VA is. Well, I know over here, this is VA, and VB is this, and this is ground. So I just, but everything is relative. So to change this circuit over here to this one, I just subtract this value of VB from everything. And so VA will equal 18.74 plus J11.55 minus 6.449, this is in parentheses, plus J16.38. Now, when I go to ground, if I subtract 6.449 plus J16.38 from 6.449 plus J16.38, I get 0. And where I had ground before, I will get minus 6.449 minus J16.38. So I think that would be a lot easier to do it that way, to mark ground as 0, and then just when you get done, figure out what the voltage is at that spot, and then subtract it from everything. So that's how I would do it.